Okay, so we're going to learn about our last type of quadrilateral, and it is called a kite. So properties of a kite is they have exactly two pairs of consecutive or of congruent sides, and those are the consecutive sides. So if you notice, it's not the opposite on this. This side and this side are congruent, and then this side and this side are congruent. That's why they're marked that way. Okay, and then it has the pair of opposite angles that are congruent. This angle and this angle are congruent, ABC, ADC, and then the diagonals are perpendicular. And there's more that goes into that, like these sides are going to be congruent to of the little triangle. So if you look, there's 4 little right triangles inside of there, so we'll use that at some point. All right, so if each quadrilateral below is a kite, we're going to find the missing values. So on this first one, we have the kite, and we have the angle that's 85 and the angle that's 43. Well, all the angles in a quadrilateral add to 360. We learned that at the beginning of the unit. All right. And we've used up 85 and we've used up 43. Okay. And so if we do that calculation, 360 minus 85 minus 43, we get 232. So that's what's left for the two angles that are left over. Fortunate for us, these two angles are congruent, so that all we have to do is take that 232 and divide it by 2 to split it up equally, and we will have 116 for these two angles. Okay, so then moving on to the next one, we actually know these two angles are equal in the kite. It's going to be the two obtuse angles that are going to be congruent. So if you're looking, they should be obtuse. Okay, and they're opposite of each other, and they're going to look. They're attached to both the short side and long side. And so that means angle J is also 82 degrees. Okay. And then to do the angle K, we can do 360 minus both of the 82s minus the 71, and we'll be able to get 125 degrees. So then moving on to number 3, okay, we're going to work a little tighter in the triangle or in the kite with those little triangles that the diagonals form. So the first one I asked for is PTQ, which is this here, but we know this intersection is perpendicular, which automatically makes that a 90-degree angle. Okay, so that's helpful. And then PQT is this here. So if this is 90 and we have 37, I can do 180 minus 90 minus 37, and I will get 53. Okay, the next one I asked for is QRT, which is this angle. So then if this whole angle is equal to this whole angle, this little part here is also going to be equal to that little part here. Okay, those angles aren't bisected, but the guy across from it that's cut in half by that diagonal, not in half, cut in 2 by that diagonal, is also going to create congruent parts. So if that is 37, let me clear this up a little bit so we can see. If this is 37, then this part is also 37 degrees. Okay. So number 4 is going to be a lot like that, but let's look at number 5. It's a pretty big problem. All right, so we're looking first for angle 1. Well, again, if this is a right angle, okay, and if you look at this triangle here, I know that I have 180 degrees minus my right angle minus the 65, and that'll leave me with what angle 1 is equal to, which is 25. Okay, that diagonal is bisecting these two angles. So these two angles are bisected. The longer diagonal will bisect. The shorter diagonal will not. Okay, and so angle 2 is also going to be 25 degrees. Okay. All right, then angle 3. Well, if you notice, it's at that intersection where they're perpendicular, so it's going to be 90 degrees. They intersect at a right angle, the diagonals do. This angle here and this angle here are going to, I'll use 2 markings instead of use the 1 markings, are going to have to be congruent, because these 2 longer triangles these are congruent. They're identical. And the two smaller triangles, they're going to be congruent. Okay, so that means their corresponding parts are congruent, like we learned in our triangles unit. All right, and then angle 5 is we're going to have to do a little work for. So let's go ahead. We're going to find angle 7 next, because angle 7 is going to be 52 as well. So if this angle here is 52, that angle there is 52. And I say that because that's going to be very helpful to us to find angle 5 and angle 6, because we know that all the angles now in this triangle here add to 180. So we can do 180 minus the right angle minus 52, and we'll be able to get 38. Then angle 6 also has to be 38. Okay, they're almost like mirror images of each other. So if you were to look at this a little differently, to help you know what angles are congruent, this is a mirror, and the top and the bottom are going to match exactly with the congruent. If it's facing that direction, it doesn't matter which way. The longer diagonal is your mirror. So like on number 3, this is your mirror, and so you can know it's congruent there. And number 6 is going to be a lot like that one. All right, let's look then at number 7. It'll be a little different. We know that WX is 14. I'm going to label that. And WR is 8. We need to find RZ. Okay, well, this and this are congruent. So if I can actually find RX, I will have found RZ. So if you look at this little triangle here, it is a right triangle. And I know 2 of the 3 sides. So we're going to once again use the Pythagorean theorem. Okay, a reminder that C is your hypotenuse. Okay, your longest side. Longest side is opposite the right angle. So 14 is going to be my C squared. So I'm going to have A squared plus 8 squared is equal to 14 squared. And you could use X in place of A. You don't have to use A if you don't want to. It's what we're trying to find. Okay. And so I'll simplify that. X squared plus 64 is equal to 196. I will minus 64 from both sides, and I'll get 132. I will square root both sides, so that X is approximately 11.5. Okay, it'll round. So RZ is 11.5, as is RX, because they're congruent segments. All right. If we do number 8, we'll go ahead and do that. AC, this entire thing, so I'll do a little curly brace for that, is 38. And ED, that is 41. Let me move my curly brace to the other side. So if we look at this right triangle here, I actually know that shorter side. If that whole AC is 38, we'll do 38 divided by 2, and so that this part is 19. Okay, so what we're missing and we're asked to find is CD, and it'll be X, and that's our hypotenuse because it's opposite that right angle. So we will do 41 squared plus 19 squared is equal to X squared. So X can be in different parts. If you do 19 squared and 41 squared, you're going to get, and add them, 2042 is equal to X squared. You will square root both sides, and you'll get approximately 45.2 for CD. Okay. All right, we'll do one more Pythagorean theorem to get some practice. So we'll do number 9. RS is 10 and RU is 9. Okay, and we are asked to find QS, which is this whole thing. But we'll find that whole thing by first finding just this section. So we'll let this be X, but then we have to remember to, at the end, to go find the entire QS. This is just part of QS. Here's your right angle, so 10 is going to be our hypotenuse. So we will do 9 squared plus X squared is equal to 10 squared. So I will have 81 plus X squared is equal to 100. I'll subtract 81 from both sides. I'll have X squared is equal to 19. And then I will square root both sides. And I'll get X is approximately 4.4. And then remember, though, that that's only this part. And we were asked for this entire QS. So I will do 4.4 times 2 so that QS is equal to 8.8. Okay. Let's look at number 11. Number 10 is just like that. Well, at least one of the two we've just done. Number 11 is talking about angles. And remember, these two angles here are going to be congruent, okay, to each other. Okay, they are the ones that are in between the non-congruent sides. T and V are between congruent sides. They're not congruent to each other. All right, so those angles are congruent, so we'll just set up an equation. 3x minus 13x minus 32 is equal to 7x plus 22. I will minus 7x from both sides. At the same time, I'm going to add 32 to both sides so that I get 6x is equal to 54. Divide both sides by 6 and I'll get x is equal to 9. Okay, let's do number 12. It's asking now for angle L, so measure of angle L. So once we find x, we will have to plug it in. But again, it's talking about these two congruent angles. So I will do 8x minus 31 is equal to 5x plus 23. I will subtract 5x from both sides and add 31 to both sides so that I get 3x is equal to 54. I will divide both sides by 3 and get 18 for x, but that's not the end because we have to go plug it in. So I'm going to do 5 times 18 plus 23. I'm going to do 5 times 18 plus 23. I will get 113 degrees for that angle L. Looking at number 13, we're still dealing with our angles, and we're still finding x. But the two angles that have equations, they're not equal. Angle A and angle C are not equal to each other. Angle D and angle B are equal to each other. So this is also 109. So what we can do is we can set up an equation where we use the fact that all the angles are going to add up to 360. So I'm going to do 5x plus 14 plus 3x plus 8 plus 109 plus 109 is going to be equal to 360. Now we're going to combine all of our like terms by adding our x's. So we'll have 8x. And then adding all of our numbers together, we're going to have 240 equal to 360. Subtract the 240 from both sides. And we'll have 8x is equal to 120. If you divide both sides by 8, you're going to get x is equal to 15. Okay. Let's do number 14 because it's pretty different. All right. It's given us two angles that are in this right triangle. So what we can do is add those two angles up with the 90-degree angle and equal them to 180 since we're dealing with a triangle. So pay attention to whether you're talking about the triangle that's a part of the kite or if you're talking about the entire kite. Because this one's adding 180 where the one before was adding to 360. But we're only talking about that section of the kite. All right, so if we go ahead and simplify and combine our like terms, we are going to get 32x is equal to 96. So if you take that 180 and subtract the 90 and then subtract the 1 and then add that 7 over, you'll get 96. And then divide both sides by 32. And x is going to be 3. It didn't ask for x though. It's where it's a little different too than the previous problem is we're looking for STV. And if we trace STV is this angle here. But remember this angle and this angle are congruent. So I will do 9 times 3 plus 1 and we'll get 28 degrees for angle 4. Not angle 4, sorry. Number 14. All right. Next problem, we are supposed to find the measure of FGJ. That's this angle here. Okay. In order to do that, though, we have to, one, know that and recognize that that's 90 degrees. Two, we need to know this angle up here, okay, so that we can add all three angles up in that triangle to be 180, because that'll be this triangle here, but we're looking for this. That's a question mark. All right, but these two angles are equal, so in order to find x, I'll set those equal to each other. Okay, I'll subtract 2x from both sides while adding 1 to both sides. So I get 3x is equal to 12. Okay. Divide both sides by 3, and I'll get x is equal to 4. Okay. So then to get that angle down there, I need to actually find this angle here. So I'm going to do 2 times 4 plus 11, so 19 degrees for that angle up there. So to get this missing angle, all the angles in a triangle add to 180. I've used up 90 degrees. I've used up 19 degrees. And when I subtract that, I'll get 71 degrees for my missing angle. All right, last problem. We have this angle as being 4x minus 7, but that also means this angle here is 4x minus 7 because those two angles are equal. And this is a 90-degree angle. So we know that all three of those angles are going to add up to 108 degrees. Then, once I have x, I can figure out how to find NQP, which is this entire angle. Okay, but I need x in order to do that. So I will do 11x minus 23 plus that 4x minus 7 plus that 90 degree equals 180. And we're doing that because this right triangle here, I have all three angles to work with in that. All right, so if I simplify and combine my like terms, okay, and moving things around all at the same time, all right, because I'm combining my x's, I'm going to have 11x and 4x is 15x. If I do that 180 and I subtract the 90, add the 7, and add that 23, I'm going to get 120 degrees, not 120 degrees, just 120, and divide both sides by 15, and I'll get x is equal to 8. Okay, so then to find NQP, if I can find just this part of the angle, doubling it will give me the entire angle, or I could plug it into each of those angles and add them. It'd be the same thing. So I'm going to do 4 times 8 minus 7, and that will give me 25. And then since these are both then 25, I can just do 25 times 2, and I'll get 50 degrees.